Good afternoon, everyone, and welcome to this brand new session. We are dealing with friction, and I'm hoping to wind off this friction today by all means. Lecture number 4, and we are dealing with the smart friction, which is your static friction. And we had seen in the previous case that the static friction can change its magnitude and it can also change its direction depending on where the body wants to move. Uh, it can change its magnitude, it can change its direction, but it can only get to a maximum value. The maximum value of static friction is known as limiting friction, and that value cannot be changed. And that is equal to mu s multiplied by n, where mu s is known as the coefficient of static friction, and n is the normal reaction force. We had seen some examples where we had seen how friction changes its magnitude and how friction changes its direction. Remember, and one thing you must always remember, whenever the friction is static in nature, its value is not known beforehand. We will have to look at what type of condition is there. Once you understand the condition, then only you can say what is the value of static friction. It can be 0 and it can go from 0 to a maximum value. Value of static friction is not known beforehand. What is known beforehand, what we can understand beforehand, is the direction of static friction. To get the actual value of static friction, you will have to see what type of case is there. So this is the question. Oh, before moving any further, let me just first tell you, we have seen two coefficients of friction. We have seen static friction and kinetic friction. We have seen two coefficients of friction, mu s and mu k. Remember, as an important note, the value of mu s is always greater than the value of mu k. Mu s is always greater than mu k. The other words in which we say this is, we say static friction is always greater than kinetic friction. This is how we say in normal day-to-day life that the static friction is always more than the kinetic friction. Basically, when we are saying this, what we are basically meaning is the value of mu s is more than the value of mu k. Uh, in day-to-day life, you would have seen that it takes more force to start the motion of a body and less force to keep the motion of the body continuing. For example, if you have a car at your home and sometimes the battery is stuck and you are not able to start the car, and you ask your friends or neighbors to push your car, they will feel that to first start the motion of the car, it takes a lot of effort. But once the car has started to move, it takes less effort to actually keep it moving. That is why, that is because of static and kinetic friction. That's an example in which you can understand. Once something is at rest, it will take more effort to start the motion. Once the motion starts, it is easier to continue with the motion. Yes or no? Do we understand this? We can also draw a graph between, and we had seen, we had seen the case of static friction changing its value from 0 to maximum. So if we have a body on ground and we draw a graph between the frictional force and the applied force, the graph of frictional force versus applied force looks like this. This is for a body kept on ground. The graph looks like this. I hope you can understand this graph. On the y-axis, I have drawn the frictional force, and on the x-axis, what we have drawn is the applied force. Now you can see in this blue region, this entire blue region, what we have is this graph is a straight line. Why is this graph straight line in this blue region? Why is this graph straight line in this blue region? In this blue region, the graph is a straight line. Why it is a straight line? Because we will find out that the applied force and the static friction have equal values. When force is 0, static friction is 0. When force was 5 Newton, static friction was 5 Newton. When the force was 10 Newton, the static friction was also 10 Newton. Do we remember that? Yes or no? And that is why this is a straight line, and this angle, how much would be this angle? How much would be this angle? It would be 45. Why this would be 45? Because here your static friction is equal to the applied force. Both are equal. Therefore, the angle has to be 45 degrees. This is the static region. Motion does not start. But it reaches this value. What is this value? This is what? This value of static friction is which value? This is the maximum value of static friction. It has reached its maximum value. The maximum value of this static friction is FL, and that is equal to mu S multiplied by N. After this, static friction cannot increase. If you increase the force beyond this point, up till here, the blue region, it was static region. The body was at rest. There was no motion between the body and the ground. The body was at rest, it was static. But after this, the body starts moving and friction gradually reduces. And you can see, then the friction acquires a fixed value. How much is this fixed value? This is our twin brother, who is a simple, straightforward guy. And this is how much? This is your kinetic friction, which is mu K multiplied by N. As you can see, this kinetic friction is always going to be less than your limiting value. So after here, from here onwards, the body starts to move, motion starts. This is the kinetic range. Do we understand this? Yes or no, this graph? Okay, so this graph will help us in understanding how the body moves and how the friction changes from static, the smarter one, to kinetic, the simpler one, and how the body moves. If you have understood this, I'll give you a minute to draw this graph. This is an important graph. It has come in exam many times. Then I will give you a question based on this. Are we ready for the question? Yes or no? No, yes. Draw this graph. Once you are ready, please let me know. And the question is already ready for you to solve. Get the answer and stay happy. Remember, one more note you can write. Whenever friction is static in nature, the value of friction is not known. You should remember this. It depends on case to case, how much is the value of static friction. So remember, whenever the friction is static in nature, the value depends on what type of question it is. You cannot tell the value of static friction in advance. Everyone has noted this down? Then comes the first question. Are we ready for it? This is the first question. A similar question to what we have done. Now everything is put together, and now you are given two values of mu. I hope you are able to understand and solve this question. A body of mass 1 kg, and here G has to be taken as
Sir, once can you scroll before one?
What happened?
Once can you scroll before one, sir?
So much of time. Okay, take it, write it. Let me know once you are done.
Sir.
Okay, so this is the question. Here the value of G has to be taken as 9.8 meter per second square. A block of mass 1 kg is at rest on a rough horizontal surface where coefficient of static As you can see, static friction is more, 0.2. Kinetic friction coefficient is 0.15. Find the frictional force if a horizontal force, case number 1 Newton acts on it. Case number 2, 1.6 Newton acts on it. Number 3, 2.5 Newton is acting on it. You have 2 minutes to give me the answer. Yes, are we getting the answers here? Looks like everyone is busy in solving it. I'll give you 1 more minute. Okay, I think I've given you enough time to solve it. Let us now go ahead and solve this question. How are we supposed to solve it? We just have to do simple things, and if we do them correctly, we should be there with our answers. Let us move on to the first case. In the first case, what we see is this force which is applied here is equal to 1 Newton. If I draw the free body diagram in this case, this would be equal to mg. This would be equal to normal reaction. Now, first thing first that you must calculate is you can calculate first what is the value of limiting friction. The body can only move when this force is more than the limiting friction. We understand this, yes or no? Let us first calculate the value of limiting friction. The value of limiting friction is given by mu s multiplied by n. The value of mu s is 0.2. 0.2 multiplied by the value of normal reaction is mg. It is 9.8. So as you can see, the value of limiting friction is 1.96 newtons. Do we understand this? Yes or no? We understand this, yes or no? Now the value of this force is 1 newton. The value of limiting friction is 1.69, 1.96 newton. We all understand that the motion cannot start. So the value of friction would be static. It will be in the backward direction. The friction would be static in nature. We understand this, yes or no? And the value of the static friction has to be equal to 1 newton. Remember, it is smart. It is the smart force, and this is equal to 1 newton. Everyone understands this? Yes or no? Part number 1. Everyone got the answer, I guess, for this part. Now let me move on to the next part where I have made the same force, the applied force, as 1.96 newtons. In this case, what is going to happen? Same case, value of n is same and the value of limiting friction is same. So basically what is going to happen is the friction would be reaching its maximum value here. The friction would be reaching its maximum value here and it would become equal to FL, and this FL is 1.96 newton as well. We will say that here the motion is just about to start. Motion is just about to start because the value of friction has reached its maximum value and it cannot increase any further. Do we understand this? Yes or no? Here the motion is just about to start, but it will be equating the value. So the value of friction would be still equal to 1.96 newtons. That takes us to the third case where the value of this friction, the value of the applied force was made 2.5 newton. Now this is much higher compared to the value of static friction. So static friction cannot stop it. This body will move. And in which direction this body is going to move? The body is going to move in this direction. Do we understand this? Yes or no? This body is going to move forward. No one can stop it. But the friction will still be there. The friction would be kinetic in nature and it would be in the backward direction. What would be the value of this kinetic friction? Can anyone tell me? It is the simpler friction. What is the value of this simple friction? So that will be equal to mu k. Remember, we now have to use the value of mu k. Mu k is 0.15. Yes or no? 0.15 multiplied by n, and n is 9.8. If you multiply it, I think you are going to get 1.47 newtons. Yes or no? No, yes. Everyone got this answer? Can I have raised hands from everyone that we got this answer, sir? Okay. Now, I can ask you a third question. This body is moving, forces are not equal. Can you tell me what is the acceleration of this body? Obviously, the acceleration of this body is going to be in the forward direction. Can anyone tell me what is the value of acceleration? I'll give you 2 minutes to get me the answer. So, anyone got the answer? How are you going to get the acceleration? The body is going to move forward.
1.03.
1.73.
1.027.
1.02. Yes. So basically what you got to do, you have to see how much is the force in the right direction. This is 2.5 newtons. Then what is the force in the leftward direction? 1.47 newtons. That is the net force. That must be equal to mass. Mass is 1 kg into A. From there you will get the value of A. Do we understand this, everyone? Yes or no? Now remember, the value of static friction is always more than the value of kinetic friction, but sometimes it is not given whether the friction it is not given separately. Mu s and mu k are not given separately. They only give you the value of mu. They only tell you mu is this one. So how do you do such questions? Well, if only one value of mu is given, then you will have to be smart. If it is static friction, you can take that mu as equal to mu s. If it is kinetic friction, then you take that mu as equal to mu k. So not many times, not every time they will give you the value of static friction mu s and mu k separately. They will just give you the value of mu. Then you will have to be smart enough to understand that, okay, we will use it as static friction. You will also use it as kinetic friction. We understand the concept now. You will if mu s and mu k are not given separately, whatever mu is given, we will use it wherever required. Do we understand this? Yes or no? Okay, then I will give one more question on the same thing. Everyone is ready? This is the question that I am going to go. Question number 2. The angle of repose for a body is given as 45 degrees. Angle of repose is given as 45 degrees. So whatever that means, I don't know. Now I have a condition where the angle is 30 degrees and the mass of this body is, let us say, m. So I am solving this question as general question. You just have to tell me what type of friction is acting on this body and what is the value of the frictional force acting on this body. Will this body move or will this body not move? You have 2 minutes to do it.
So the block will not move.
Will the block move or will the block not move? The block will remain at rest. Yes or no?
Yes, sir.
Because
Static
the angle is
friction.
less than the angle of friction or angle of repose. Now the block moves at rest. So what type of frictional force will act on this? No
Static
doubt.
friction.
Static friction. And as soon as static friction comes, remember it's a smart one. So you have to be smarter than this static friction to understand what is the value. So what is the value of static friction? You draw this. Yes. What is the value of static friction? Yes. Anyone who's smarter than this static friction? Remember, the static friction is smarter than us. Yes. What is the value of static friction? Yes? Anyone? See, static friction without knowing Newton laws. He's getting smarter than us. We know Newton law. We also know Newton. We also seen his face. Yes? No one? Well, the body remains at rest. I draw the free body and I see that the force which is trying to pull it down is mg by 2. And since I am static friction, I am smarter friction. I will apply the same force in the backward direction, Fs, and the value of Fs in this case will be equal to mg by 2. Do we understand this? This is the value of static friction in this case. Are we understanding this, or this is going above our head saying bye bye? I increase the angle to 37 degrees. This is the same experiment that you are supposed to do. The angle of repose is still same. You must know what is sine 37, cos 37. Do you know this? Yes or no? Okay. Then again, the same question. Does the body move? What type of friction? What is the value of friction? You have 2 minutes to do it.
Sir, body will be addressed.
Yes, becha?
Body will be addressed.
The body will be at rest. So I got one part of the answer correct. The body remains at rest. Yes. What type of friction then?
Static friction.
Then the friction has to be Fs. What is the value of static friction?
G 4/5, sir. Static friction.
By 5? This is mg. This is mg sine 37. Sine 37 is 3 by 5. This is mg cos 37. 4 by 5. This is our old friend, normal reaction. Yes, what is the value of static friction in this case? Blue case.
305.
Static friction in this case, it is smarter. It has become 3 by 5 mg. As you can see, this value is more than the previous value. So it is increasing its value. Remember, it is a smarter friction. Everyone is understanding this, or this is going above our head saying bye bye? Same question, angle has been changed. We are doing the experiment. Again, the same thing. What is the condition of this block? What type of friction? What is the value of friction?
Sir, kinetic friction.
No, not. We don't call it kinetic friction. The block is
Sir.
just about to move. Call it just about to move. Just about to move. And the value of friction is limiting FL. The value of friction is limiting FL. Do we understand this? Oh, bye bye. This is mg. This is mg by root 2. This is mg by root 2. And the friction has reached its maximum value. Now it cannot do anything. This is FL. And the value of this FL is mg by root 2. Last case. 60-degree angle has been made. M is there. Again, the same question.
Sir, kinetic friction.
Now the body is definitely in motion. The body is in motion, moving in motion. And it is very easy to see in which direction is the body moving. The body is going down. What is the value of friction?
Sir, 3/2, sir.
Hmm?
Root 3/2, sir.
Huh?
Root 3/2 mg, sir.
Root 3/2 mg, sir. You have 2 minutes to get the answer and stay happy.
Yes, √3/2 into mg.
Root 3/2 into mg, right?
mus √3/2 mg.
I don't know what are you saying. Mu s. Tell me the value of mu s. If you don't tell me about the value of mu s, what will I do? Everyone is confused. That is the problem, that we don't use our brains. Don't use your brain. Static friction could not confuse you. Kinetic friction confused you. See, the simpler guy is always the mastermind killer. Bazikar, Shah Rukh Khan, the simpler looking guy is the cunning fellow. The smarter guy gets trapped. The simple looking guy is a cunning fellow. mg cos 60 mg by 2 mg sin 60
mg/2√3, sir.
root 3/2 and normal reaction. Ding 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 ding. Ding 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 ding. And the friction is kinetic in nature. The simpler guy, the simple sober guy, Fk. How much is Fk?
Sorry.
Fk is mu multiplied by n, my dear friends. That is fixed. He is the simple fellow.
√3 mg, sir.
Value of mu is how much?
Sir.
Yes?
√3. Sir.
The value of mu is 1 by root 2, my dear friends. 1 by root 2 or 1? Remember, this mu is tan of the angle of repose. Yes or no? So this mu, my dear friend, is 1. And this n is mg by 2. So my answer is mg by 2. That is your kinetic friction, my dear friends. See, the simpler guy has deceived you. Anyone is looking, hey. Here, the normal reaction is also changing, my dear friends. Don't forget. Angle changing, normal reaction. See, no one could get this answer. Simple. I have not done anything drastic. Mu is tan of angle of repose. That was 1. So I have used it for mu k, I am using I use it for mu s, I am also using it for mu k, because as I told you, if mu is not given or only one mu is given, you take it for mu s and you take it for mu k. Mg by 2, everyone gave root 3 by 2, 1 by root 2, this and that, sir. Mg by 2 is the answer, sir. Do we understand, sir? This has gone above our head, sir. Saying bye bye, sir. Bye bye. Everyone understood this? Yes or no? Chalo. So remember, this is how things are done. Be careful about such questions, because whenever questions are going to come in a JEE, the questions are going to be framed in such a way that they are bound to, the questions are going to be simple, my dear friends. Every question that comes in a JEE is a simple question. And as soon as you see previous year question, you must be feeling happy. Oh, this has come in previous year. That means it has to be simple. That's why it has come. But then you must be careful while doing it, because if you get emotional and stop thinking from your head and start thinking from your heart, it is Newton's laws of motion, not heart's law of motion. Your heart is not going to teach you physics. It can be used better elsewhere. Brain tells you how to do physics. Don't get into emotions in physics. This is the next one. Let's see who comes up with the answer for this one. A block of mass m rests on a rough horizontal surface. Same question came in last year JEE. And we did this question in the class 2 years back. But still there were some people who could not do this. See, sometimes your emotion gets better of you rather than your brain. So we have to do physics with brains and rest of the things with your heart. A block of mass m rests on a rough horizontal surface shown in the figure A and B. Coefficient between the block and the surface is U f is equal to mg x at an angle theta. The vertical side of the block. Find the condition for which the block will move along the surface. This is how fast you must be reading the question in an examination hall. Not only reading, understanding it as well. Because you will only get somewhere around 2 minutes to solve the entire paper. And if you are spending 2 minutes in reading the question, then there is no need to solve the question. Go and read the next one. Get used to reading the question. While reading the question, also solving it. Okay. And the problem with you is now the paper is on computer. When the paper was of my age, we had a diagram at least in given, so that we can draw the free body diagram there as well. You guys have a bigger problem because the question is on the screen and you cannot write on the computer screen there, because you don't have this pen with you. So you will have to draw the diagram. So as you are noting down the question, you also look for the diagram. So you have a bigger task than I had when I appeared for JEE. Let's see who gets me the answer for this one. There are two cases given, case number A, case number B. I think case number B came last year. Case number B came. Let me see if I can find that question. So just for your reference, this was the question that came in the JEE. And this is the question that we are doing. And as luck has it, they are the exact copies of each other. Remember, I keep on telling you, JEE is not cleared in the examination hall. What we are doing here is we are clearing JEE. Same question can come in your examination. Same question will come in your examination hall if you do enough number of questions. JEE is about smart work. You do each question as if this question is going to come in the paper. And you have to remember it for 2 years. JEE, no student clears JEE in the examination hall. You just cannot clear JEE in the examination hall. Because if you don't study for the 2 years and you didn't say, I'll clear JEE, then no one is going to do that. You are clearing JEE now. So do it. Every question is like that. It's a question for JEE. Yes, my dear friends, do we have anything that looks like an answer? Feels like one, sounds like one. Yes or no? No, yes. Or everyone is chilling out. Good time to chill out. Let's chill out. मौका भी है, दस्तूर भी है, sort of thing. Shall I do the needful? Or are you trying? Huh? You have 2 minutes to show your talents, else I'll show mine. Chalo, I will solve one part for you and I hope that you can do the next one. Remember, there is nothing that you don't know that I have not told you, of which a question can come in a JEE. There's nothing that you will not know. The only thing is you have to know how to apply it. So this is the question, my dear friends. F is applied like this, not a problem. The only thing we got to do, the only thing we know to do is draw what? Huh?
Free body diagram.
Draw a free body diagram. That is what we are going to do. So this comes here, dick, mg. This comes here, pick, normal reaction end. This is not going to jhag, but here, apart from the jhag, we have to also see that this force is like this. So we have to resolve this force into two components. Now remember, the value of theta is given with the vertical. So this becomes mg sine theta. And this becomes mg cos theta. Do we understand this, or this has gone above our saying bye-bye? As soon as you draw this, well, the answer is this is not going to jhag. So it's not going to go jhag. So you know this plus this has to be equal to this. From there, you can find out the value of normal reaction. What is the value of normal reaction that you are going to get? Normal reaction will be mg taken common 1 minus mu cos theta. Yes or no? Now mu cos theta. 1 minus cos theta. Do we understand this? Yes or no? Now, we have to find out the condition for which the block will move along the surface. Now, only one mu is given, so we should take it as for the block to move, the friction should reach the limiting range, right? The applied force must be equal to more than the limiting friction. Yes or no? So, I find out the value of limiting friction. Do we understand this? FL is mu s into n. So this is mu mg into 1 minus cos theta. Now this is your limiting friction. Your applied force, which is trying to pull it, is mg sine theta. So your mg sine theta should be more than or greater than this limiting friction. Yes or no? So this limiting friction must be less than or equal to your mg sine theta. Do we understand this, bacha? That is the condition. Now after that, this is pure maths, and we'll have to just solve it using some math. And that math, I don't know whether you have done it. We have to do some trigonometry. This 1 minus cos theta can be changed into sine square theta by 2. Do you know this? This mg sine theta can also be changed into sine theta by 2 multiplied by cos theta by 2. Do you know this? Now, if I apply that maths here, which I don't know whether you know or not, this is simple trigonometry, and this is not a class of trigonometry. So once you understand this, physics ends here. Physics ends here. So just physics ends here. Then you apply simple how to convert from angle to half of the angle, how to convert from half of the angle to twice of the angle. You have to apply this, and you will get this condition, and you can just note down this condition. And if you would have known this condition, that question that came in JEE could have been done in a flash. So the condition that you are going to get, wrong color. So the condition that you are going to get is this one, cot of theta by 2. So cot of theta by 2 should be greater than or equal to mu. This is a simple inequality that you can solve. Do you understand this? Yes or no? Do you understand how this cot theta would have come? 1 minus cos theta is 2 times sine square theta by 2. Sine theta is 2 times sine theta by 2 into cos theta by 2. Then do jig, 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 and you get this. Now, since I have done jig, 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 jig for you for the first part, I would hope that you can do the jig, jig for the second part. And that second part was the question that came in the JEE. So you have an added bonus with that. 2 minutes you shall have, and I'll wait for your answers. Well, it seems like we have run out of time for today's class. I had no idea that the time is over. So I will give you this question as a homework. So I hope that you can solve this question as a homework. Can you do that? Yes or no? Apart from this, I will give you one more question as homework because this variation of the question has come. So I will give you another variation of the same question. And if you are lucky enough, you might just find this question in your examination hall in your paper. Or if you are very unlucky, this question might come in this year JEE. So, and your JEE is the next year JEE. Well, anyways, this is the question that I'm going to give you as an additional question for practice. Similar concept, same thing. I will give you 3 or 4 different types. So if you are unlucky that this question comes in this year JEE, maybe the next question that I give you will come in your JEE as well. A body of mass m rests on a horizontal floor with which the coefficient of static friction is mu. We desire to move the body move by applying a minimum positive force F. Find the magnitude of F and the direction in which this will apply. That means you have to move a body by applying a force F. How should you apply the force so that you can move the body with the minimum force? See. And the answer is not horizontal. Hey, pull. No, the answer is not horizontal. So now with this chapter, we will get smarter. And if someone tells you, okay, you want to pull this, how you should pull this, you don't just start pulling it in the horizontal direction. You know, I know physics. I have known Newton. I have seen the Newton's ways and I have studied Newton's laws. And I know static friction. He is smart, but I am smarter than him. So I will use the best possible angle and pull the block or push the block. You must understand whether it will be pushing the block or pulling the block. Pushing the block will be easier or pulling it? I told you that in the previous class. Pushing or pulling? Well, if you don't know this, you'll have to also find it out. This is the question. I'll see you in the next class. Take care. God bless all of you. Bye-bye.
Thank you, sir.